So what we're going to be focusing on today is the four main algebraic functions and how we can reflect them and how we can transform them, move them up and down, left and right, and then some additional interpretation. But let's just take a moment to write down the four main algebraic functions. So there's straight lines, there's parabolas, there is hyperbolas, and there are exponential. And if I had to talk about these particular types of functions, we normally talk about the standard form. And so for the straight line, they generally use that notation. For parabolas, we have the standard form and we have the turning point form, which looks like that. And then sometimes we even have what's called the root form, where we have x minus x1. Give me a thumbs up if those things look familiar to you. Give me a thumbs up if those look familiar to you. Give me a thumbs down if they don't look familiar. Okay, because this is kind of like if you look back on the video lessons we've done, there's a lot of information and content about this, but it's good to keep coming back to it. Now, if we talk about the hyperbola, we generally think about the standard form like that. And if we talk about the exponential, we generally look at something like that. So again, that's the standard form. Give me a thumbs up if the 3 and 4 look familiar to you, the standard forms of those particular types of functions. Okay, awesome. Now, I want to ask you a question. Which of these 4 functions, and you can answer with the answer like number 1 and 2 or number 1 and 4. So I'm going to ask you some questions about these 4 algebraic functions. Which of these functions has an axis of symmetry? Or sometimes I use the symbolization A/S. Which ones of these have an axis of symmetry? Now remember, what does an axis of symmetry do? It cuts the graph in half. Exactly. It's like you could fold over that line. So if we imagine, like, I suppose we can have little model graphs here that show us kind of what these look like. Maybe like one like that, one there. The one that I know for sure has an axis of symmetry is the parabola, because the parabola can be cut in half on that. It folds across that axis, that vertical axis. So it's definitely going to be a number 2. But there's another one that has an axis of symmetry. What's that going to be? I see Yoni and Sonic have it. So if you imagine hyperbolas that look something like that, you can also have an axis of symmetry that looks like that. And there's actually a second axis of symmetry for the hyperbola. So the correct answer is number 2 and number 3 have axes of symmetry. Number 4 doesn't have an axis of symmetry, and I'll show you why. Number 4, the exponential graph typically looks like that. And there's no ways you can cut that in half to be symmetrical and folded. Okay, so it doesn't include number 4. But new question. Which of these graphs have asymptotes? Now that sounds similar, but it's not the same thing. So this is not an axis of symmetry. Which of these 4 have asymptotes? Lines that you get closer and closer to but never cross is one way of kind of describing that. Okay, so if we look, I see lots of people are saying 3 and 4, and you are correct. In the hyperbola, we have a horizontal asymptote that looks like that. And then we also have a vertical asymptote that looks like that. And you'll see that these green curves, the function itself never crosses the blue or the yellow. So the hyperbola has 2 asymptotes. The exponential function has 1 asymptote over here, 1 horizontal asymptote. Okay, so that's good basics to know and just to revise from time to time. And so let's move forward from that unless there are any questions. If there are any questions about these ideas, let me know in the chat. Otherwise, I'm going to move forward. All right, then let us move on. So here is the type of skill sets I want to work on today. We need to be able to take any function and reflect it over the x-axis, or reflect it over the y-axis, or move it left and right or up and down. So let's have a look at let's have a look at the rules first. Let me give you some rules. And this is general rules that will work for all functions. So if you want to reflect over the x-axis, what do I do is the question. So if I've given a function and I want to reflect it over the x-axis, what do I do? If I want to reflect a function over the y-axis, what do I do? And then if I want to move something up or down, what do I do? And if I want to move something left or right, what do I do? These are the rules that I need to be familiar with. And in this exercise, the functions that we're dealing with are, this one over here is a parabola. Well, that's f. And this one over here is a hyperbola. Okay, so what are the rules that we can use to help us? If you want to reflect over the x-axis, what you need to do is you change the sign. You change the sign in front of y. And if you want to reflect over the y-axis, you need to change the sign in front of x. Now, what do you notice about this rule? What do you notice about the relationship between the axis that you're reflecting over and the sign that you're changing? What do you notice about that? Maybe put your hand up or let me know in the chat if you notice a certain pattern over here. Let's have a look. So all that I was saying here was that if you want to reflect over the x-axis, you change the sign in front of the y. So it's the opposite way around. If you want to change this, if you want to reflect over the y-axis, you change the sign in front of the x. It's the opposite way around. Yeah. Now, if you want to move up or down, all you need to do is add or subtract the amount you want to move up or down from the y coordinate or the y value. So, but let me leave that up for now. I'll tell you what, let's go to that second. Let's do this one first. So I want you to attempt to take the f of x and reflect it over the x-axis using the rule that I've just shown you now. So take the rule that I've just shown you and apply it and try and find me the function that you get when you take y equals 4x squared plus 5x plus 1, which was the function f, and reflect it over the x-axis and tell me what you get. And if there's a question, please raise your hand and we can chat about it. Otherwise, go ahead and then pop your answer in the chat.
Mr. Ace?
Hmm.
I'm not sure if you saw this one. Sino Sipo was asking if you can please explain what an asymptote is again.
Okay, an asymptote. Okay, well, while everyone's working on that, so an asymptote is, in the case of an exponential function, it's almost like a tail that gets closer and closer to a line, but never gets there. So for the exponential graph, the yellow line I just drew there is an asymptote because this bit of the graph gets closer and closer to the yellow line, but never gets there. So that's an asymptote. And the other function that has an asymptote would be the hyperbola. And you'll notice that it has these like little arrows. And what that means is it gets closer and closer to the vertical axis, but never gets there, both here and there. And then over here, you'll notice the tail gets closer and closer to the green one here and here. And these are called asymptotes. Okay, I hope that helps a bit. So if we change the sign in front of the y, at the moment it's plus y, well then it will become negative y. And another way of thinking about this is if I have a coordinate, say I have a coordinate like over here, and I reflect this coordinate. So let's just say it's in line with 3 on the y-axis. If I want to reflect this coordinate over the x-axis, what's going to happen is that coordinate is just going to have its y sign change to the opposite thing that is negative. So you can actually visually see it. Like if you reflect, this original blue point over the x-axis, you get this point here, which is the y value has changed. But now, in order to get it back into standard form, I'm going to have to do something. But let me just look at the comments and see if everyone agrees. Okay, perfect. And now to get y by itself, I multiply both sides by -1, sorry. And I get minus 4x squared minus 5x and -1. And so that is the f of x reflected over the x-axis. Okay, now I want you to do b for me. So do that by yourself and see what you can get. And pop it in the chat. We're doing the green one now.
Mr. Ace?
Yeah.
There's some confusion about how you got rid of the minus y. Can you please explain it again?
Yep. So what I did was I multiplied this side by -1 and I multiplied this side by -1. And when I did that, -1 times minus gives me a plus, but we don't write the plus. And then over here, if I multiply this by this, I get minus 4x squared. That by that, I get minus 5x. And that by that, I get -1. And so that's where it came from. So I hope that was helpful. Thanks for picking that up, Level. Yeah.
Thanks, Mr. Ace.
Cool. So for the next one, we need to have g, the function g, because the question is about g. And so I like to write it in terms of just y. And if I'm reflecting over the x-axis, I must change that to be like that. But now I have to deal with this negative y again. And how do I deal with that? That's what I want my students to try out. So Alwande, your question about why do we have to multiply by minus? Why can't we leave it to be minus y? So in Paul, you could leave it like it is, but normally the question, they often say leave in standard form, and standard form is to have the output or y by itself. So it's standard form to just leave as a positive y. So what I'm going to do in this one is I'm going to multiply both sides by minus 1. And just to show you kind of how that works, I'm putting a bracket around both of these. Now, I think most of you will be comfortable with the y being positive now. But this side is a bit tricky. Why is this side a bit tricky? Who would like to share why this side is a little bit tricky, or what do I need to watch out for? I can see some of us making a little mistake in this question. What do you think a student would be most likely to make a mistake with? The sign change? Yep, okay, I agree. And they would forget to multiply this minus 1 by both of these. And so you should get minus 2 over x plus 5 and then plus 6. And I think a lot of students, so it's the sign change and the fact that the minus 1 needs to be applied to both. And so that would be the hyperbola reflected over the x-axis. An example, let me just show you kind of what's happening. Like if we looked at f, the very first graph f that we drew, it was that one. So let's say it looked, say, something like that. So this is from, I'm going back to A now. The reflection over the x-axis would most likely look something like that, okay? Because it's reflecting over this line over here. And so what this algebraic trick allows us to do is it allows us to know the equation of the thing that's reflected. If we had to deal with the hyperbola, the first hyperbola G would have looked, okay, it's going to be a bit more complicated with the hyperbola because of all the dotted lines. So I'm not going to clutter up the screen. But essentially what's going to happen is it's going to reflect over this part here. Okay. So I hope this little visual here helps you understand what's going on. Now, I want you to move on to the blue one. So I want you to do C, and I also want you to do D, which is the pink one. And now you have to reflect F and G over the y-axis. Okay. Why does the denominator stay positive? Oh, that's a fantastic question, Caitlin. The reason it stays positive is you can think of minus 1 over 1 as the same as minus 1. So if you imagine, first of all, you have to be happy with the fact that minus 1 over 1 is the same as minus 1. Are you happy with that, Caitlin? Or at least do you feel comfortable understanding why that's true? That minus 1 over 1 is the same as minus 1. Okay, so now, imagine this. Imagine when you go minus 1 times the top and the 1 multiplies to the bottom and 1 doesn't change anything. And so that's why this stays positive. Okay, good question though. Thank you. Okay, let's do C and D. I'll give you a bit more time. Pop your answer for C in the chat when you feel like you've got it. Now watch out with this one, because when you reflect over the y-axis, you change the sign in front of the x, but there is a squared term here. And when I write out 4 times minus x times minus x, I actually find I'm getting 4x squared for that. And so I see some of you have minus 4x squared, but I would disagree. I would say that the first bit here is 4x squared. Now, what is the rest going to be? Well, the rest is going to be a little bit easier. It's going to be minus 5x plus 1. Give me a thumbs up if you understand the sneaky bit over here that gives you this. I know that I would have caught a few of you with that. Okay, fantastic, fantastic. All right, then on to D. Let's do the pink one. What do we think we're going to get for? So reflecting over the y-axis, I should really just change this to be minus x plus 5 minus 6. Okay, now I can see in the chat people are getting this right fantastically well, and that's perfect. Sometimes they want us to write this in a form that leaves the x as a positive. And I just want to show you a little trick. So this is completely correct if you wrote this, but if you want to make this bit here look a little neater, we can use another trick. And that trick is to multiply the top and bottom by minus 1. If I multiply the top and bottom by the same thing, it doesn't change the overall fraction, because I could just cancel them out and that wouldn't be a problem. But what it means is it makes the denominator look a little bit neater, which can be helpful sometimes. So let's see how this works. Minus 1 times 2 is minus 2, and minus 1 times minus x plus 5, I actually need to multiply this in. So minus 1 times minus x is x. Minus 1 times plus 5 is minus 5. And then the minus 6 gets left all by itself because these were only applying to the fraction. Now, that's not obvious, but I think the idea when you look at the minus ones, yeah, I think that you can convince yourself of it. So give me a thumbs up if you understand my extra little extension, the little trick I was showing you there. Thumbs down if you feel I lost you there. So, or just to show, because I have lost some of you, all I did, this is completely correct, but I'm just showing you that if you multiply the top and bottom by minus 1, you're not changing it in any way, but look how much neater the denominator looks. And so all I did was I multiplied this by this to get minus 2, and then minus 1 times minus x plus 5, that just gives me plus x minus 5, like that. Okay, cool. I love how the new Zoom thumbs and ups and downs, like they jump around. Can you see that level? Like the thumbs, like they don't just stay. It's like must have been an upgrade or something.
Yeah, there was a recent update.
Yeah. Thank you. Can you explain the one for 4 minus x again? Oh, okay. Yes. Okay. So Tato, are you talking about this one here? Okay. for question C, I had to reflect it over the y-axis. And so I changed the sign in front of the x. So there's the x. Now, what I did was I actually I call it like, I write it like this, so you can clearly see the thing that is being changed. And where there was an x before, I now put a minus x. But now the problem is this is actually minus x squared. And when I square this, I actually end up with basically saying 4 times minus x times minus x. And then I have this bit over here already. But these two negatives actually give me a positive. And so I get 4x squared for that bit there. Okay. All right, everyone, it's time for a break. So let us stand up. I want you to turn on those cameras so we can all see everyone's wonderful faces, and we can be in the team on the bus or the ship or whatever vehicle you want to be on together. And let's just stand up and stretch. Oh, I feel like you're going to touch the ceiling. You don't have to get onto your tippy toes. You can just stand up straight and just stretch up. Oh, this feels fantastic. You're missing out if you're not joining the movement. And then stretch to the side. Oh, my goodness, I'm creaking, but it's good.
Same.
It's so nice. Okay, let's shake out these arms. Let's just shake them, get nice and loose, like you're, I don't know. And shake this out. Shake it out. I'm sure there was a song like that many years ago. Shake it out. And then, there we go. And then shake out your legs. And let us do a little arm stretch. Like this. Oh, my eyes are going a bit wonky. Other side. Okay, let's loosen up the shoulders by just rolling them. Roll them back. There we go. And then maybe we should do some eye health since we've been staring at the screen. Why don't you look off as far away into the distance as you can? So look at an object that's far. If your room is small, then you can only look thin, but look somewhere else so that your eyes get a chance to relax. And just look at that point, the furthest point in the room. And let your eyes focus on that point. And that should be taking care of your eyes as you stare at the screen. And then you can bring them back. And let us do some cardio. So let's do 20 jumping jacks. Make sure the space around you is clear. We're going to start in 3, 2, 1. Let's go. 2, 3, 5, 6, 7, 8, 9. Halfway. 10, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Oh, okay. I feel alive. I hope you do too. I notice I'm not as out of breath as I used to be. Maybe I'm even getting fitter. Who knows? So brain break time. So for our new students, what this game is we try and make 24 using all 4 numbers on the cards, and we're only allowed to use normal operations. And then let us know in the chat if you think you've solved it. Oh, there's my shortness of breath. Takes a while to kick in. Whew. But yeah, so if you can use these 4 numbers to make 24, then the glory is yours. And just put it in the chat. Who can? So a wonky, let's have a look. 5 times 5 plus 4, that would give us 29. But 5 times 5 plus 4, or maybe Oh, -4. Okay, -4 plus 3 does indeed give us 24. Yes. Or the other option that Tova, 5 times 3 plus 5 plus 4. It's also 24. And Awande also agrees. So does Gabriel, Yazi, Emmanuel, Sonic. Okay, cool. Red's fallen. What about blue or yellow? And Corsi has said 7 times 4 minus 8 minus 4, which is 28 minus 4, which is 24. So that yellow has gone. So it's just blue that's remaining. So anyone got blue? And blue, Havila has said 7 plus 7 plus 2 times 5, and Sonic has agreed, and Alwande has agreed. And so we have got 24. Marang agrees. Marang. And who else agrees? Coronela also agrees. So yeah, we are golden. All right, well done, everyone. Nicely done. There was definitely like speed there. Like it was like they were coming thick and fast, which was
you're very good at this math 24 now.
I don't know. I need to like maybe make like a maths 35 or something now. but I want you
a bit.
Yeah, but it will be as catchy. But all right, let's head back to our lesson. I hope that you guys had a bit of fun with that. Okay, so in the second part of the lesson, what we're going to talk about now is instead of reflecting these functions over the x-axis, over the y-axis, we're going to talk about moving them left and right, or horizontal shift, or up and down. And I'm just going to give you a little example of how this is a little bit different. Now, let me just clean this out of the way before I get started. So I'll do a very simple example, like a simple parabola, and show you how you can move it left and right or up and down in terms of the process. And in the process you learn about, you can apply to these questions that we're doing here. So take a nice simple graph like y equals x squared, because it's nice and simple. We all know what that looks like. So y equals x squared. It's just a happy parabola going with its turning point at the origin. So if I want to shift this graph up, let's say I want to move it up by 2 units. All I need to do is I put a +2 on the end because I'm increasing the y value by 2. So it's moving it up by 2. And if I did that, my new graph would just look like that, where the vertex or the turning point would just be there. So that the vertical shift is quite straightforward. If I wanted to move it down by 3 units, then the whole graph would just move down by 3 units. So I would just change the formula to have a -3 on the end, and let's see, I'll probably be about here. Then the graph would look something like that. So the vertical shifts are not very difficult. What is difficult, or a little bit more difficult, is the idea of how do you shift something which horizontally. So say we have the same graph like this, but now I want to move it 2 units to the left. Okay, now 2 units to the left would get me from here to here. And then the new graph would look something like that. It would have to be at -2, I guess. Give me a thumbs up if you understand the logic of what I've done so far by moving it 2 units to the left, and it looks like this. It's the red one is the new horizontally shifted graph. Okay, now, how do we deal with this in the algebra? Now, we can't just add a +2 at the end. That would shift it up or down. So what we need to do is we need to transform the x value. So the original function was y equals x squared. Something has to happen inside this bracket. And the question is it going to be x plus 2 or is it going to be x minus 2? That's what we need to decide. I would like you to tell me in the chat. I don't want to give away the ending. I want you to tell me in the chat, what do you think is going to go inside this bracket to handle this transformation of moving 2 units to the left? Okay, I think you guys might know this. You've seen this thing before. This isn't going to be x minus 2. Even though going to the left is going the negative direction, the algebra is actually going to be x plus 2 squared. And let me show you why kind of why it works like this. Think of it this way. If I said to you, find me the x-intercept of this new graph, this red graph that I've just drawn. This is the red graph. If I said find the x-intercept, you'd normally make y equals 0, and you'd have to solve this equation. What is the answer to this equation? The answer to this equation is x equals minus 2. So that's what, and that matches the graph I have here. So that's why the formula has to have an x plus 2 in it, so that you get an x-intercept of minus 2. It's the other way around. And so sometimes that can help students understand why with the horizontal, it has to move the opposite way. The other thing I want to show you is that look at my red graph. Look at how its y-intercept is up here. How do we see that in this particular graph? And the way we can see it from this algebra is to multiply this out and see what we get. So we get x squared. Then we get plus 2x, plus 2x. Then we get plus 2x. Then we get plus 4. And so this y equals x plus 2 squared, the original graph moves 2 units to the left, can also be written as x squared plus 4x plus 4. And that would be a 4 up here. This would be the y-intercept. And so I think if you can hold this picture in your head of realizing that when you move it left or right, the algebra and the picture agree. They don't say different things. They say the same thing. All right. Now, after much talking by me, let us have a go at doing E. So I want you to take, as best you can, the yellow f function and move it 1 unit to the right and 6 units up, and try and give me a new equation that takes this into account. So try and do E for me. I think that this one over here, the 6 units up, might be the easy one to think about first. See if you can do that first, and then you can go from there. Maybe I should give you another little. Why not write the whole thing like this to set you up, to get you moving, to take into account what's going on here? And maybe if someone's feeling generous, they can tell us what they think goes in these spots here. Pop your wisdom into the chat. Who feels like they can tell me what goes in under these red lines here, which basically it's this shifted 1 unit right. So moving to the right would be going in that direction. So Daniel, I absolutely agree with you. It's x minus 1 that goes in here. Yeah. And so now what you have to do is get this parabola into standard form to get me my final answer. So this takes care of that bit, that takes care of this, and this has 2x's, so I have to replace that with that. And now what is my simplified parabola going to be? It may require some multiplying out. So you don't have to do as many steps as I'm doing, but I'm just kind of showing you what is my final parabola value going to be. Or the standard form of this transformed parabola. So I'm looking for like terms, and it looks like to me, I'm going to get that. Give me a thumbs up if you felt okay following that. Give me a thumbs down if you felt a bit lost. Just want to get a feel for the group in terms of if you followed that logic or, okay. Okay, now for those who are unsure, I really encourage you to ask a question. We're going to go on to doing this one, F, where I take g of x and I need to shift the hyperbola by this. So basically, I want everyone to try and do the blue one, and actually let's do the pink one. But for those who are feeling a bit unsure, I'd love to have a further conversation with you about how I did the one I just did. I'll put that one in yellow. So do you have to multiply out the brackets? You don't, Emmanuel, if you know how to do that quickly, right? Okay, well, let me put it this way. If they just say find the equation of the transform function, then in some ways you could just stop here. But if they say find the form of the new function in the form y equals, then you're going to have to isolate y and in standard form and simplify it down to this. But you don't have to multiply it out. Some of you will know shortcuts for squaring a binomial. Awanda is asked, why was it x minus 1 and not minus x? Very good question. In the previous questions, I was asking about reflecting. And when you reflect over an axis, you change the sign in front of the opposite variable. from question E, I was shifting. And so these are questions where you're shifting left and right or up and down. And that's why. So I hope that answers your question all one day. Okay, so what about the blue one? What are we going to get for that? So 2 units up feels like I should just add a +2. So that's 4 units left is a bit trickier though. So what am I going to do to take this thing 4 units left? Now there was a +5 there, and I'm guessing this is going to, well, I'm not guessing actually, but I should get a +4 there. What do I need to do in that bracket? Can we do it by completing the square? Oh, no. So I would not use the completing the square. Only use completing the square when they ask you to use completing the square. It's quite a tricky technique, and you don't want to like, it's like saying, someone says to you, won't you go and fetch this for me at the Checkers down the road? And you go, I'm going to go to the Checkers on the other side of town. Like, you don't want to do that unless you have to, unless someone tells you you have to go there. Okay, so 4 units to the left, this should actually be x +4, because moving to the left, the opposite of that would be going in the positive direction. So then the final thing is going to be x +9 +4, or 2 over x +9 +4. Aha, in the previous question, why wasn't the 4 negative when multiplying out? Because the -1 times the -1 gave me a +1. And so then when I multiplied the 4s in here, I got a +4 because it was 4 times +1 there. So is -6 + 2 -4? Yes, it is. Why is it -4? Awonke, can you be more specific? Where is it -4? It's not -4. It looks to me like it's +4 down here. It's x +4. And then x +4 plus the 5 gives me the x +9. Maybe you could maybe clarify, because Nosipo also asked something about that. So I'm a little bit trying to figure out what you mean. Okay. So if you, yeah.
I think they mean the -6 + 2.
-6 plus, oh, yes. Well, oh, goodness. Oh, I figured it out over here. I just, yeah, I self-corrected. We call that an autocorrect. Where you make a mistake and it jumps back like that. All right, thank you. Love the eagle eyes there. Okay, let's do the pink one. Let's do the pink one. And then, in fact, you know what? Let's do H, which is the yellow one. How much time have we got? We got time. We got time. And we're going to do another blue one. So let's do these remaining 3 to finish the lesson today.
Says,
Yeah.
shouldn't our +4 there be -4?
Oh my goodness. Clearly I am having a moment here. Yeah, you're quite right. So it wasn't an autocorrect, it was a incorrect. Thanks everyone. You know, my eyes feel like they're going to pop out of my head. I think I need to go stare up into the distance for a bit. Cool. But it gives me great confidence that the team is there. Okay. So what is G going to be? So moving it down by 9 units, that should just be 4x squared plus 5x minus 8. So that's a nice easy one. Why is the denominator plus 9? The reason it's plus 9 is because you have the plus 4 and then you already had the plus 5 here. And so the plus 4 and the plus 5 gives you the plus 9 down here. I hope, does that make sense? So because you're moving 4 units to the left, the 4 units to the left gives you the x plus 4, and then there already was a plus 5 there. Of h. And maybe I can even write it in one step. What is my new equation going to be for h? What's it going to be? So it's going to be 2 over x plus 6 minus 8. Yeah. And I see we're running out of time, so let me speed this up a little bit. For g of x, if it goes 4 units down, it's just going to be minus 4. And then the thing that was x is going to become 1 unit to the right, which that will become x minus 1. And so my final answer should be 2 over x plus 4. So, because that'll be, that's right, and then minus 10. Let's get rid of that. So, and it should be y equals 2 over x plus 4 minus 10. All right, Level, could you just put the poll up? I know we've run a bit out of time here, but just to review while you're taking the poll, today was about reviewing the 4 algebraic functions, just doing some recapping, then looking at how do we reflect over the x and y axis, and then how do we move all types of functions left and right or up and down. Now, in the thing today that we've done, we focused on parabolas and hyperbolas, but this will also work for straight lines and exponentials. So the methods we've used here, even though we focused on these 2, it'll work for the other 2 as well. Okay, and so the main idea for this week is we're just learning how to not just draw the graphs, but how do we do some of the interpretation questions that come along with them. And so in the next lesson, what I'm going to do is we'll start to look at these types of questions, which are the typical interpretation questions, where we have to, often interpret the information. And then today's skills were about building up to those types of questions.